Hello. This was a word problem from our Systems of Equation unit. Student asked to see a solution, so I'm just going to pop this up here now. So one type of fertilizer has 30% nitrogen. The second type of fertilizer has 15% nitrogen. If the farmer needs 600 kilograms of fertilizer, that is 20% nitrogen, how much of each type should the farmer mix together? So the setup for this one can be a little challenging. One thing that helps me work through it is I think of it as I'm finding the number of nitrogen particles in 600 kilograms of fertilizer. So the first step with this problem is I need to declare my variables. So we're going to say step 1, declare variables. This is really important to do, especially as you get into harder problems, because this step will help your thinking. So we're going to say let x represent amount of 30% mix, nitrogen mix, and we're going to say let y represent amount of 15% nitrogen mix. Oh, I can still just, so there's my let statement. So the next step when we're working through a system of equations is set up equations, or set up our system. So the farmer needs 600 kilograms of fertilizer. So that means in total I have x plus y equals 600. And that one's usually pretty straightforward. We number that equation 1. So what I'm interested in is I want to figure out, of that 600 kilograms, 20% of it has to be nitrogen. So if I think of it like this, if I find 20%, which in 20% can be written as 20 over 100, of 600 kilograms, that represents the number of, we could say, particles. You can't see my fingers are making quotation signs because that's a simplification, but we can think of 20% of 600 kilograms is going to represent the nitrogen part, the nitrogen particles in there. So what I can then do is I can say, okay, so that's going to come from two sources. It's going to come from the 30% nitrogen mix. So that means if I take the 30% nitrogen, so we're going to take some from the amount, so whatever x is, 30% of that is going to be nitrogen. And if I take whatever the y is, 15% of that is going to be nitrogen. And I now have my equation to set this up, because what I've set up is this represents 30% of whatever x is, this represents 15% of whatever y is, and when I add those together, I'm going to get 20% mix of a total of 600. So of course I can then simplify this to, we'll cancel that out. So 2 times 600 is going to give me 1200, so I end up with 1200 divided by 10, which is going to be 120. So just a little math there. And I could then say 0.3x if I wanted, plus 0.15y. And I don't like decimals, so let's multiply everything by 100. So I'm going to get 30x plus 15y equals 120, and then we add 2 zeros. Not the most efficient method to get there, but we've gotten there nonetheless. And that's going to be equation 2. So the step 3 in when we're working through our systems of equations is to solve the system. So this problem lends itself really nicely to substitution, since I can easily isolate from equation 1. So we could say x is equal to 600 minus y, and we'll call that star. We're going to sub star into equation 2. So I'm going to get 30 times 600 minus y plus 15y equals 12,000. So now we're going to do a little algebra. So we're going to expand the brackets using the distributive property. So we're going to get 18,000 minus 30y plus 15y equals 12,000. Little algebra is going to give me negative 15y. So negative 30y plus 15 will give me negative 15y equals, and then we get 12,000 minus 18,000, and that's going to give me 6,000. Now if I've done this right, oh, pardon me, it's not 6,000, it should be negative 6,000. If I've done this right, I should get a value of y that is less than 600. So therefore y is equal to negative 6,000 divided by negative 15. Let's get my trusty calculator out just to do this one. 6,000 divided by 15, and we get 400. So therefore we have 400 kilograms of the 15% nitrogen mix. So if y is equal to 400, we can then substitute in and see that x is going to equal 600 minus 400, which is equal to 200. Okay, so that means now what we do is we have 2 more steps to do. Let's do a check. And our check is we'll do a left side, right side check. So we're going to substitute into equation 2. So we're going to see 30 times x, which is 200, plus 15 times 400. If we work this out properly, we should get 12,000. So we're going to leave the right side the same, and I'll just take my calculator and plug this in. 30 times 200 plus 15 times 400. And sure enough, my left side, right side check works. So I feel great about that. And so, sorry, this is step 4, is my check. So therefore, I do the last step, which is my therefore statement. So step 5 is my statement. Therefore, we need 400 kilograms of the 15% mix and 200 kilograms of the 30% mix. And I'm done. As always, if you have any questions, don't hesitate to ask, even if you're not in my class. Have a wonderful day.